So by way of just letting you guys know what you're in for here today, I will start with just giving you guys a quick introduction of who I am, because anytime I see somebody up on a giant screen, I like to think why they're there, and understanding what it is they do is typically a pretty good start. I'll speak a lot about machine learning and AI, and traditionally just analytics in general, and how they've kind of changed throughout time within the business structure and what they're being leveraged for today. I'll use one of my probably favorite examples of all time to describe when AI is leveraged versus when traditional means of analytics and or investigation can be used. And I call that the toilet example. It's literally an example of tracking a toilet throughout a big box store. So pretty ridiculous, but also a fantastic kind of segue into when AI and machine learning become important. And then I'll talk a little bit about what I like to think of as kind of the AI do's and don'ts from a business perspective. And I'll get into why that's super important down the road. But as you guys are all studying to work presumably in some type of business avenue, given that you're at Bentley University, or at least you're going to be rubbing elbows with those working within the business realm. It's pretty important to understand how, not only how businesses leverage AI and machine learning, but also how they think of AI and machine learning from a business premise. And it's a pretty odd construct, but generally speaking, it's kind of a hot button topic within organizations these days from a sales perspective. And I'll get into that quite a bit down the road. And then lastly, I'll talk a little bit about my current role at Arnica, which is an app, and we can discuss a little bit of how they work, how machine learning is integrated in our solution. And I can get into a couple of examples and conversation about, generally speaking, how we're leveraging all of the things I'll be talking about throughout this presentation. All right, so first and foremost, as Mark said, I am a Bentley Falcon. I spent quite a bit of time within the CIS sandbox as a tutor hired by Mark, not just because we shared a first name. I like to think there were other reasons for it, but that may have been the lion's share of the thought process. I also spent quite a bit of time in the Fed Challenge team. Was actually a two-time competitor with the Fed Challenge team. So studied managerial economics as my primary and computer information systems as my secondary at Bentley. And I've spent just about every minute outside of Bentley working in the technology field and not at all within economics or finance. So for those of you who are freshmen, who are maybe trying to figure out what you're studying, or thinking, hey, you know, I am being exposed to a lot of new ideas and maybe I would have liked to change, just know two things. One, you can always change. And two, you don't necessarily get stuck working in exactly the same field that you studied. I've migrated around quite a bit. So always things that you can kind of leverage in other fields. So after leaving Bentley University, I was a Profitect owl. I joined a startup called Profitect, which was effectively a behavioral prescriptive analytics suite. So this was a large-scale big data crunching suite that was implemented at box stores, CPGs, retail industries, many names that you guys would be aware of. If you've shopped there, they've probably leveraged some type of software within this realm, and Profitect was the leader in the space for quite a few years. I started at Profitect as a product owner and a developer of what we called the Profitect Academy, which was a web-based help and training platform, which was capable of training, certifying, and even offering promotion suggestions to bosses for the users that were using our tools. So really ingrained in the actual organization that was leveraging our suite. I then moved on into customer success at Profitect. This was more of a consulting and implementation role. But customer success is a very new concept within the business realm in general. So very, very happy to answer any questions that you guys might have about what a CSM is, what customer success does within organizations, specifically tech organizations and those that have implementations. Towards the end of the presentation, I didn't really get into that due to the topic here and how much we have to cover, but I'm definitely happy to speak to that. Profitect was a largely pattern-driven system that used behavioral analytics to push tasks out to people working on the ground level, what we called the edge user, and effectively allowed somebody that was in an HQ or a corporate capacity to be able to automate messaging going out to fields. So very different from a task manager that maybe would require a push methodology. Instead, the construct here was that the system itself actually analyzed and generated those examples. And this is the system that was in use with the toilet example that we'll get into very soon. I was incredibly fortunate to be at Profitect when it was acquired by Zebra Technologies, which is one of the leaders in the space of hardware creation. So Internet of Things, think RFID, cameras, CCTV, basically anything that you can think of that would be a data capture point within an organization, whether it be retail, CPG, delivery. These are the handhelds you see UPS, FedEx, and US Post Office walking around with. If you do go to Fenway Park and scan a pass that allows you to enter the stadium, it's very likely that this type of device is going to be what you leverage upon entry. So this was really, from the thought process, was kind of a match made in heaven, right, for both organizations. It combined Profitect's intelligence automation with an incredibly broad-reaching analytics detection system that allowed my job to really grow into some very interesting constructs, such as leveraging big data and IoT components, Internet of Things components, to really drive optimization and automation of business practices. And then lastly, in my current role, I'm head of customer success at Arnica, sometimes referred to as arnica.io, being the kind of tag and a URL for apps. We are a behaviorally based risk mitigation system for the development operations and security background. So effectively what we do is our tool integrates with what's called source code management tools. Think GitHub, and Azure DevOps, and it increases protection for the source code from cybersecurity threats such as exfiltration risks or backdoor access due to excessive permissions. I will get into a little bit more of exactly what Arnica does towards the end of this conversation, and I'll speak to how we leverage machine learning within our tool. Before I do that, I just want to kind of segue by talking a little bit about why business and tech are so integrated, and specifically why artificial intelligence and machine learning are such a good marriage for the business space. And just to get it out of the way, why am I speaking specifically to this topic during this presentation? Well, primarily because I see the marriage of business and technology as being one of the greatest factors in the decision for me to go to Bentley University. So not only because I think that obviously the sandbox and the CIS program at Bentley is fantastic, but the ability for everything you're being taught at Bentley University, whether it be computer information systems or econ, it's all kind of seen through a business lens, which is really important for making sure that you understand the practical applications of all the things you're learning. Otherwise, it's effectively philosophy instead of business practice. And I'll, again, get into that in a moment, because you really can't discuss artificial intelligence without, at some point, getting into philosophical differentiation. So for starters, let's just talk about why businesses are shifting into leveraging things like AI and machine learning. From a high level, it's the shift in the way businesses are operating today. So the good things about business in 2022, and really for the past 5 years, is they're becoming increasingly global, increasingly technologically driven, more innovative, more agile if they're going to survive. And most frequently, or most recently, the biggest shift has been remote. A lot of times you're making decisions or you're trying to impact organizational change in a location that is drastically different from the current location that you're studying in or working in. Perfect example, this is not just me giving a presentation to you guys from my home office. I'm actually a permanently remote employee right now. So my HQ is in Atlanta. I work with people from all over the continental United States and in EMEA and APAC, being Europe and Asia. And every day I'm having to interact with people and make decisions based on information that I cannot gather physically. So with that, businesses have had to shift the way that they think about the problems they're solving, and specifically how they optimize their processes and how they ensure that they're bringing the best solutions for organizations. The real kind of crux of the point here is that with every good change that we've seen in business over the past 5 to 10 years, we've also seen increased complexity. We've seen a lot more global policies and regulations, specifically in the EU, over the past 10 years that have changed the way tech has been organized and how it's functioned within the US based on global practices. And we've seen a ton more data coming out of processes and coming out of business elements that previously we never had visibility to, and we didn't have the ability to analyze. So with all of this, businesses are constantly having to respond to scenarios and changes with immense speed. And most frequently, a lot of unknowns, things that we're not aware of how they're going to be organizing within a business sense, don't know how customers or personalities are going to respond to them. And because of all this, we've turned to new technologies and new, more sophisticated ways to analyze our business. And the biggest ones, or the biggest terminologies that you're going to hear, are AI, artificial intelligence, and ML, machine learning, being leveraged in that capacity. And there's a third that kind of gets ignored from a sales perspective, which is why many people have not heard of it. But DL stands for deep learning technology, and it is an offshoot or a subset of machine learning that organizes and structures the technology slightly differently. But each of these has kind of their own power, so to speak, and their own positioning within businesses. But generally speaking, businesses are bringing these in for 3 reasons. The breadth of data is unmanageable for either a person or traditional tools. At Bentley University, I'm sure even those of you who are in IT 101 are aware that Excel spreadsheets do end somewhere, and it's not possible to crunch all data within them, right? So contemporary solutions would be something like Microsoft Access, which is Access still being used within IT 101?
Access is still being used.
Fantastic.
Access,
so you got, sorry?
Listen, 150, and we talked a little about Access 101, but Access is used in the database course now.
Fantastic. So to maybe update my example slightly from the traditional Bentley IT 101 to maybe some of the terminology that you've been hearing these days. Probably the big data schema, or the big data world, has been shifting a lot over the past 10 years. And you're seeing a lot of new tools like Google BigQuery and MongoDB come out, and they're expanding the ability of an end user to do very simple things within a very large data set. But generally speaking, what they're all organized around is some kind of either language-based or object-based language, like SQL or Java or Python, which still requires terminals for end users to go into to be able to tell the system what to look for. And we don't always know. So when outcomes or the causes of a problem are uncertain, or when data is subjective and we don't know what is going on within the data, it makes it very difficult to query that data. So the next logical step is to start leveraging more sophisticated tools, which is where AI and machine learning come in. So just as a point of reference, not everybody is really aware of kind of what the distinction is between all of these terminologies, but generally speaking, AI is an umbrella term that's used to cover all practices within the statistical realm that try to turn a computer into a human-like feature. So effectively, when you speak to artificial intelligence in the form of Siri, or when you speak to somebody on a phone line that is offering support or help, they're giving you a bunch of options. Very frequently, it's a very simple form. But it would still fall under the guise of AI, generally speaking, as you're trying to turn a robot into an element of behavior that mimics computers. Now, obviously, within that, there are many different subsets where it gets a lot more complex. But the biggest one that I want to discuss today is machine learning, which is a class of artificial intelligence that's generally classified by its use of training methodologies to improve the outcome of an existing model or equation. So think, I'm going to, generate a specific rule, and I don't know if the rule is going to turn out good or poorly, and I run it 100 times. And then I have the ability to manually go into the outcomes and determine which ones were positive and which ones were negative. Machine learning has many different use cases, but one of the most prevalent ones is called looping, which effectively creates a closed loop information form that brings the outcome of the model back to the original machine learning model, and it can actually change itself. And this is the biggest implication probably from a use case, or this is the most prevalent use case for a reason. It has the biggest implications on optimization within businesses. So there's two general areas that are being leveraged today, which are supervised learning and unsupervised learning. And we don't need to get into the technical aspects here because we could spend an entire afternoon discussing them. But generally speaking, a supervised learning model requires that the model be trained by effectively inputting history or continuous output from the model. It's really good for optimizing things like numerical thresholds or altering logic that can make a pattern better or a behavioral system better. And then unsupervised learning is generally used for what's categorized in business terms most frequently as anomaly detection. And this is where a business can have a very large data set that they know very little about and chuck it into a model that can then spit out set categories, set attributes that can be used to define that data set. It's really good at defining behavioral profiles or categorizing or creating buckets for subsets of data that we don't understand yet. So I'm going to go into, in a moment here, the example of kind of the traveling toilet within a big box store. But before I do that, I just want to take a moment to pause. I've said a lot. Hopefully, much of it was understandable, but any questions off the cuff that you guys want to throw in the chat or unmute, please feel free to jump out.
If you have a question either in the room or a comment or on Zoom, please unmute or just scream. I see none, which means you must be speaking perfectly clearly.
All right. Thumbs up if you're still awake in the chat. No, I'm just kidding. Kidding. Don't do that. If I don't see any thumbs, I'll feel bad. All right. So, all right, going into my toilet bowl example. And again, the reason why I think this is super important to understand is it gives a construct, it describes some concepts that are really important surrounding how AI can be leveraged in a very simple and kind of meaningful example that you wouldn't think machine learning or AI would be leveraged in. So to kick this example off, I'll give a very, very simple premise. An organization came to us and said, we sell a lot of things within our store. And one of the problems that we currently have is that we are losing sales for toilets because they are being put in the wrong aisle. Now, that seems like an incredibly simple problem. And it seems like something that you would never assume that machine learning was going to be leveraged to solve. It seems like you could just tell somebody right off the cuff, go put the toilets in the right aisle. Please stop putting them in the wrong aisle, right? Because we can make some assumptions. Toilets don't move themselves. And somebody is probably doing something wrong. But if we begin to digest this problem, we find that there are actually a lot of additional details here that go beyond the scope of what a human is capable of doing with repetition that is going to lead to good outcomes every single time. So first and foremost, we'll just start with the facts. We have a toilet. At this point, we've not implemented any technology. It's literally just a toilet. So we start gathering more information, right? How do we know that a toilet is in the wrong aisle? We have the true state or the rule. Toilets are sold and stored within aisle 4. This is the state that the business is looking to maintain. We then have the problematic state. When a toilet is in aisle 8, it is not going to be sold, right? So again, from this perspective, in terms of technology, how do we know the toilet is in aisle 8? This is where something like Internet of Things comes into play. It might be tracked via RFID. They might have cameras that are capable of reading barcodes. Some sensory element has been able to detect that this toilet is actually in the wrong aisle. In this case, aisle 8 or aisle 6, as you see in the image. Now, let's continue to build on this, right? We have a policy. We know the aisle is in the wrong place. The obvious assumption is that the above scenario should never take place, right? We could, at this point, solve this with a very simple equation or a very simple pattern, right? Push out a notification to somebody on the sales floor to move the toilet if the toilet is in aisle 6. And this would be a perfectly reasonable and complete solution to the original problem. But it doesn't allow for a lot of movement in this scenario. And this scenario will have a lot of different starting scenarios, right? So first and foremost, we're only capturing scenarios in aisle 6. Automatically, we need to adjust this pattern. Now, the slightly smarter way to approach this would have been to say, if the aisle is not 4, that's a better way to capture all aisle activity, right? But we might not know that in the very first run of this pattern that's operating. The second problem is that I have never specified how long the toilet needs to be in aisle 6. So at this point, I'm going to send out false positives to every person on the sales floor anytime somebody purchases a toilet and walks through aisle 6 with it. So what we've actually done with this solution is not solve a business problem, but instead waste a lot of people's time on the sales floor. So here's where we all of a sudden come into a point where machine learning can be helpful, because at the end of the day, the problem here is that the first iteration of this logic has issues, needs to be updated, and needs to be updated manually. So it's unrealistic to think that in a work setting, people could do this intelligibly. The other problem is that it's super expensive to both have an analyst constantly changing logic and, from a business perspective, to have people responding to output that's incorrect, right? It's hard to replicate across all locations, especially if you are a big box store with maybe 2,000 store locations across the country. And it's frankly annoying to have to change patterns over and over again because they're not working properly. It's not great for morale or for the tool that you're trying to sell. And probably the biggest issue is it requires some expertise to accurately triage why this is sending out false positives. And many engineers or analysts are not working on store level, so they're not there to actually know what's taking place. So as you can imagine, this problem can have about 100 different reasons for going wrong at the end of the day. And it doesn't make sense from a business perspective for us to collect all of those reasons and adjust the pattern. And this is where machine learning can be leveraged to very quickly optimize this solution. So if we implement supervised learning with iterative feedback loops, we can use the perceived or entered outcome of these actions to actually impact the pattern in real time. So we can do one of two things. We can ask the end user to actually provide feedback on the alert. A thumbs up, thumbs down, or a smiley face, frowning face is usually enough to let you know whether or not things are working properly. And a really simple example of this is actually when you walk into or out of a store, a restroom, or some kind of public service that has an iPad that asks you to rate the service that you've just gone through. Maybe it's a movie theater, you're walking out, you see a small iPad. That is user-based input that's being used to iteratively update a process. Maybe it's cleaning, maybe it's, requesting feedback for how well the movie was played, but it's done very manually. And what supervised learning does within machine learning is give us the ability to actually automate both the feedback and the ingestion and learning of that feedback in the model. So each time it runs, it looks at the history of all of the runs that have taken place previously and determines what the model is actually doing incorrectly and will adjust. This is really good for recognizing that thresholds are incorrect. In the prior slide, we adjusted for one of the problems by adding a time threshold. We said, okay, we can't catch every person walking through aisle 4 with a toilet. The toilet needs to have stopped in aisle 4 for 30 minutes. There's no good reason for it to be in the wrong aisle for a half an hour. So it's probably been misplaced and needs to be returned to its original aisle. 30 minutes might be a terrible time frame for that pattern to run using. And I don't have the knowledge without looking at output to determine whether or not that's accurate. But the machine learning system in its iterative loops can actually determine what the appropriate time setting is to get the best output for that pattern. Now, the big problem or hang up, I suppose, for supervised learning is that you must have defined results. You need to know what good or bad is for training purposes. In this case, lost sales, or a yes, this was positive outcome, or no, this was a negative outcome for the toilet scenario. But without that, without knowing what good or bad outcomes look like, you really can't train the model. And this is where our second element comes in, which is the unsupervised learning. If we don't know what the problem is to begin with, for example, if the customer had come to you and said, I don't know why some products aren't selling, but I need to figure it out, an unsupervised model can be used to load all of the data at once and find anomalies or behavioral patterns within the data set that can then be extrapolated, investigated, and you can determine what the potential problems for that set of, in this case, products actually are. Some catches here is explainability. Unsupervised learning is really, really good at capturing anomalies, but in its early forms, it's really bad at explaining why those anomalies exist. And scaling it is difficult. Eating lunch across the course of a day would be anomalous for me because it happens once and it seems like a standout item. But if we scale and we look at all human beings, let's say at Bentley University, everybody eating lunch once would be a learning factor that unsupervised learning would be able to use to define that lunch was not, in fact, an anomalous activity. Similarly, with a single person, if we look at my entire year, if I continue to eat lunch every day, it will stop reporting lunch as being an anomaly. In fact, it will reverse and say the couple of days that I missed lunch were actually the anomalies. Although I will say I never miss lunch, so that would not happen for me. So a couple of good examples of how what are thought of as kind of being very lofty constructs can be used in a very simple environment to produce real change for business processes. So I'm going to pause for a moment. I want to get into it, and I want to talk in a moment here about kind of one of the big pitfalls in business is using AI at the wrong time or not using AI at the right time. But again, I want to just take a breath, let you guys ask any questions or see if there are any comments at this point.
Any questions here? And nothing's put in the chat. So
I will take that as a positive sign that I've been concise and clear throughout this entire 30 minutes. Unlikely, but it's how I'm going to choose to take that. Okay. So as promised, a little bit of conversation surrounding when we do and when we should not use AI. And the why not always AI question here is kind of tongue in cheek, because this is the way organizations typically view artificial intelligence and machine learning. It's a good thing. it should always be leveraged. Well, that's not always the case. And history has given us some really good examples for leveraging products, building products at the wrong time or in the wrong avenue. So I've got a couple of real fun ones here, just to give kind of an idea of, outside of the AI construct, what that means. So first and foremost, it's very possible to build the right product for the wrong reason or the wrong market, right? Two fantastic historical examples are Silly Putty and Sticky Notes. Silly Putty was originally created to be a rubber replacement during war times when rubber was very hard to come by. It's a terrible replacement for rubber, but children love the stuff. So ended up being very sellable anyway. Similarly, sticky notes were created by accident by a designer who was actually trying to make an incredibly strong glue to hold heavy items together. Now, anybody who's ever used a sticky note, which admittedly is a crowd that's reducing each year, by the way, as things like OneNote and new tools come up, but you've seen sticky notes. Come on, entertain me for a moment. Terrible gluing application. In fact, the reason sticky notes have value is that the glue is terrible. They can be removed from things and not leave any residue behind. So again, fantastic item, terrible original marketing strategy. The opposite is also true. You can build the wrong item for a really good reason or a good market. The first fantastic example of this is Google+. For those of you who don't know what Google+ is, there's a reason you don't know. This was a product that was generated by one of the biggest tech giants on the planet to effectively push Facebook and MySpace out of the social media space. They believed they were going to be the social media product. A fantastic market and an amazing opportunity for somebody like Google. Unfortunately, the product they designed was horrible and nobody wanted to be on it. And this second example here, which I don't have too many words for, but clearly it was a... Sorry, Mark?
I was on Google Plus.
and so you can speak to potentially why it disappeared so quickly.
I think you can do unmute yourself.
That's right. You were the one exploratory user, right?
Right.
So I imagine that the image on the right side of the screen had a very similar problem. Obviously, going for what I assume is some kind of footwear market. This is actually created by a very high-end designing company, which I won't say for obvious reasons. This is being recorded, but if you've got really good eyesight, you might be able to read it on the side. Generally speaking, I don't know what they were going for, but there is definitely a market for high-end footwear, and this, I don't think, spoke to it. So another fantastic example of the wrong product, the right idea, the right market. And lastly, there are also ways to build the right product, potentially for the right market, and still fail. And again, AI and machine learning are not above these rules. Two fantastic historical examples are the IBM smartphone, which is probably one of the most important devices in all of our lives today. But at $1,100 in 1994 was not a smashing success, and admittedly sold way more than I would have thought they would in 1994 at that price point. I think they sold somewhere around 50,000 devices. Pretty impressive, actually, considering we don't know IBM as being a smartphone manufacturer today. And then lastly, and there might be some people who would argue this point, but I believe the Apple Pro stand is probably an example of wrong price, wrong item, wrong market, wrong everything, especially at $1,000 to hold up a computer that costs the same or less. So again, lots of opportunities to have really good technology or potentially really good business strategies, but they don't pan out because you went about it incorrectly. And again, this is a really good strength of Bentley. Not only do they give you technical and really good underpinnings for being able to work with either mathematics or technology, but they're merging it with business prowess to understand when to and maybe when not to do those things. So how does that apply to AI and machine learning? there are some pretty important core tenets and pitfalls in the business world when it comes to leveraging these types of technology. And I'll go through these quickly so we have time for some Q&A and some conversation towards the end here. But generally speaking, when AI is super useful, it's for two really good reasons. The first is that the correct model and approach is being leveraged that is directed towards an existing problem. And the second is high accuracy levels with even higher levels of simplicity. And what do I mean by that? Artificial intelligence and machine learning can get very complex very quickly. And for those of us who live in that world, it's really fun to make them complex. But that's actually a detriment from a business perspective, because managing them and understanding their output is really difficult in some of those instances. So do ensure that you're using the right application. And if you do choose to leverage machine learning or AI in a business in the future, please make sure it is only as complex as is necessary to solve the business problem and no more, because it will lead to failures, and actual failures in the machine learning, not the people. And also bad outcomes from a business perspective. The second one is build them for a specific problem, not because you can build a model. Models typically don't sell, solutions sell. So prioritize the value that the machine learning is looking to create. And again, err on the side of simplicity. Solve the problem directly. Don't solve everything all at once. And lastly, tailor the solution and the explanation for the use case. And I'll get into this in a moment, but it's really important to understand accuracy from a business perspective when you're leveraging machine learning, and not just from a mathematical perspective. One of the biggest don'ts is do not use artificial intelligence as a sales term. I jokingly put this graph in here, but it demonstrates a very real problem within the business realm, which is that there is it's got machine learning go-to-market strategy. And it typically consists of a machine learning feature count that exceeds the number of use cases for the end user. It has a very large number of times that the either sales demo or sales representatives leverage the word AI and machine learning. And it has an incredibly small value derived from that actual tool or feature within the product. So it's really easy to get people to pick up a phone call by using the terms AI and machine learning, but it leads to massive retention issues for service companies. And it leads to very bad reviews for products if it's not being leveraged to actually meet the product's purpose. Don't generate unexplainable or incorrect output. We talked about this a little bit earlier with that first pattern pass for tracking the toilet. But if you are constantly alerting with machine learning and the alerts are incorrect, or the end user cannot understand what the alerts mean, you've come up with a really cool and sophisticated alert system that's going to frustrate the customer. And lastly, on my don't list here is do not confuse correct logic with correct output. And this is a really tough one to describe. So I actually have a second slide on it. But generally speaking, there is a process or a matrix called the confusion matrix, which is leveraged to define exactly what outputs fall into from a category perspective for machine learning. And it's really important to add what I like to think of as kind of a third axis to that matrix. And I'll get into that in just a moment. But generally speaking, the concept here is it's very easy to say the math was right or the math was wrong. But if the math is right and it doesn't provide value, from a business perspective, it's wrong. And that is a really tough pill to swallow for people who work in machine learning and AI, because you've created this super cool thing, but it doesn't do anything. So if the Roomba were capable of driving around your floor, but never actually vacuumed anything up, it wouldn't be a fault of the drive sensors or the automated ability within the Roomba to actually traverse the floor, but people still wouldn't buy it, right? So the same premise is true in analytics. So this is a confusion matrix, and I have randomly chosen the story of Chicken Little to describe it. I'm not sure if it's a good one or a bad one, but it came to mind last night. And the concept is this. There are 4 general outcomes of an alert from machine learning. The first is called a true positive, and it can be described like this. What the model says is happening is what's happening. In this case, the chicken yells, "The sky is falling," and the event is that the sky falls. The chicken was right. The second is when the system still provides output, but in this case, it's incorrect, and that's called a false positive. You alerted, the chicken yelled, "The sky is falling," but the sky didn't fall, and the chicken is wrong. There's also a false negative, which is when there is no alert, or in this case, the chicken yells nothing, and the sky falls. And at the end of the day, from this perspective, you didn't let them know that the event was going to take place. The chicken is still wrong. And then lastly, we have a true negative, which is, again, when there is no alert, the chicken yells nothing, but the sky doesn't fall. Now, any company that doesn't use machine learning has effectively, accurately completed a true negative. You didn't alert, and anytime it doesn't happen, it doesn't matter to the organization. This one is useful, but at the end of the day, you're trying to alert. So it's not the one that's most seen from a business perspective. The false positive and false negative, as they are depicted here in red, are negatives. They are noise creators for businesses. So they are bad outcomes. And the true positive, the accurate alert, is your best case scenario for the confusion matrix or for the machine learning or pattern output. The problem is this. The standard confusion matrix assumes that the alert is meaningful. All the confusion matrix does is tell me whether or not it was accurate, but it doesn't tell me if it provided value. So at the end of the day, if I can say anything that I want you guys to walk away with from this presentation, it's that machine learning needs to serve a purpose and provide a value to function and be useful within business arenas. And if it doesn't, right, wrong, or indifferent, it won't matter. It's not going to add value. So in this instance here, if the model's definition of sky is incorrect, let's say it includes rain, well, the matrix doesn't change at all. But the value for the end user is drastically different for one that has an umbrella and one that doesn't. So knowing that end user, knowing that scenario is incredibly important, and being able to explain the output in a way that's actionable is going to be the biggest challenge. And I'll just be honest, it's incredibly hard to make sure that these patterns, these models push out explainable value. But it is the most important part about leveraging these tools in a business setting. So I'm just going to circle back here to Arnica, my current organization. We've talked a lot about machine learning, a lot about AI in the business realm. And I just want to spend one quick slide here talking about how Arnica leverages it and why it's important in the development space. So hopefully, those of you who are in development or in security at Bentley will either use this tool or certainly know of it as you leave the organization. And I invite you all to follow Arnica on LinkedIn to get updates from us. Got some pretty big news coming out in the coming weeks. So definitely worthwhile in this moment to do that. But let me first give you guys a little bit of an understanding of what Arnica actually does and why machine learning is pertinent at Arnica. As we talked about all of these business issues and specifically breadth of data and difficulty of managing them, the development ecosystem provides a really complex and difficult challenge for organizations, which is it's constantly changing as you bring in new developers, change the developers' jobs within organizations, and also when security threats shift, and they do daily, right? So security companies or every company that has any kind of development taking place will have departments that are dedicated to what's called DevOps or development operations and DevSecOps or development security operations, who exist effectively to secure the IP of that organization and make sure that they're reducing threats at all time from a security perspective. And that's a really tall ask for an organization, and especially for a small group of people within a large organization. So what Arnica does is, and by the way, earlier in my slides, you might have noticed that I had a pathway of arrows, you could say, that effectively showed me going from Bentley Falcon to Owl to Zebra, and then the last one was Flower, and might have thought that was really weird at the time. And I did too, actually, my first day at Arnica, because I didn't know what Arnica meant. But Arnica is actually so named because the Arnica flower, which is a member of the sunflower family, is actually used for medicinal purposes to remediate or mitigate burns or other conditions. And we use them in a lot of products and don't know it. Which is kind of the concept of Arnica to begin with. It lives behind the scenes and it automatically locates and mitigates risks within code infrastructures. It does this by using behavioral policies to find excessive permissions for developers within the tool and locate anomalies within code that gets pushed to the product. So it's actively monitoring each developer's contributions, and based on a behavioral profile that it is created using the history of your activity in the system, it's actually able to recognize things like code that probably didn't come from that author. The joke that we internally reference is, for those of you who are Star Wars fans, you're probably aware that Yoda has a pretty obvious dialect. He never speaks appropriately, never grammatically correct. So history would lead us to believe that a grammatically correct sentence probably wasn't authored by Yoda. So a really simple and kind of comical example of behavioral anomalies, but a really good and poignant example of what we're looking for. And the big key here is Arnica is very different from any other company that has come out in this space previously, because we don't just locate the anomaly or the threat, but we actually automate the mitigation task for the threat. So it has the ability to actually update either permission settings, configurations, or even suggest changes to the code itself when a code secret is discovered, which are incredibly dangerous, or when an anomaly is discovered in a code commit, which is effectively somebody attempting to publish new code to an existing library. So super important, and how we're currently trying to leverage machine learning to make it a little bit more easily digestible for companies to protect themselves, especially in a time right now where cyber threats are kind of a daily occurrence for large organizations. So I'm really excited to be at Arnica and be working on this. And, obviously, as I think is probably the biggest and most useful part for you guys going forward, please don't hesitate to reach out to me with any questions on LinkedIn. Like I said, check out Arnica on LinkedIn if you're interested in following kind of our journey and what we're working on, how we're leveraging all the things that we just talked about during this presentation. And, don't be strangers. Definitely want to be able to meet with and give you guys some information on what I've run into in my career so far.